There, this is for those few people who missed class today. Today is November 30th. Um, this is the notes, and then we're going to learn how to actually balance equations today. So it should be pretty interesting. It's one of my favorite things to do, so hopefully you like this. Let's start off with these notes. First of all, we have to talk about chemical reactions. And I think most of you guys were here the day we did the lab where there were chemical reactions involved, where there was color change and the blue stuff turned into like a gel. There's all sorts of different things. That bubbles occurred in one spot, gave off heat, all sorts of different things. Well, we're gonna put this in a real quick, easy definition, and what we're gonna say is chemical reaction is a process where a physical and chemical properties of a substance change as the substance with a new chemical or physical and chemical properties are formed. So what we're going to say is the properties change. And let's write that out right now. Oops, got the wrong pencil again. And what I did this time was I put the first letter of the word on there just to remind myself what I was looking for, because there's other options. We could have said other words that mean properties like traits and stuff like that, but I was trying to keep it consistent for both classes. Okay, now the chemical reaction, there's a change of properties, but at the same time, there's always a change in energy too. And so properties and energy. And so what we're doing here is we're taking these notes, but you have to copy these down as we go. And this will be turned in as an assignment. So that way I'm making sure that you watched this and you went along with us. Now there's two things that are involved in this process. The first is called the reactants, and they're the things that are going to react. So they're the things that you put together. They're the things that you throw in the beaker together to start with. So that's what we're going to start with. We'll say we put together. These are the things that are put together. And then the products are what they turn into. Now, I know that that's not a very official definition, but we don't need an official definition. We just want to know what they are, right? Okay, moving right along. All right, now, when we talked about energy, there's different types of energy. You can either absorb energy or you can give off energy. And so we have special names for these. And the first one, if it feels hot, right, that means energy's been given off. So if it feels hot, heat is leaving that thing. We call this exothermic. Right? And exo means exit, right, to exit. So heat leaves. Oops, I wrote in cursive. So if heat leaves the object, exothermic. The opposite of that is endothermic. If it gets cold, that means that heat is entering it, and it's endothermic. All right. Now I have a little misprint here. I put endo, exit. No, endo means enter. So if you'll change that also. I copied and pasted what I had written before because it's just the opposite definition, and I forgot to change the other word. Okay, so heat is going to enter the object. Okay, sounds good to me. Hey, we have some things that we've already talked about. I just said them, right? How do we know there's a chemical reaction? Because maybe it changes color. Right? Maybe it gives off bubbles, which is a gas. Maybe it gets hot. Maybe it feels cold. Right? Those are all changes that we can see. Color change. Oh, remember that experiment where that blue turned into like a gel? Maybe it turns into a solid. It just changes. So if it changes from something to something that's totally different, it became a new thing, that's a chemical change. All right? That's a chemical reaction. I got 8% on this iPad. I'm trying to reach the plug. That's why I keep looking over to the one side weird. Okay, so the concept behind this whole idea of balancing equation, which we're going to do next, is the law of conservation of mass. And all it says is that matter can't be created or destroyed. So we're saying in these chemical reactions that we have the same amount of stuff on both sides, the products, the same amount of stuff that are in the reactants, right? They're the same. And let's give you an example here. Now, look at this picture here. There's a 2 in front of this. That means I have 2 AGs, and I look over here and I have 2 AGs. It's the same amount. I have 2 N's. There's a 2 outside here, 2 N's. I have 2 times 3, 6 O's, and there's 2 times 3, 6 O's. I have 1 copper, 1 copper. I have the same amount on both sides of that little arrow. So what that's saying is that we have the same number of atoms before the reaction as after. They're just in a different format. They're with different things. Okay. Now let's label this. Now I have these words up here. We'll just draw arrows. The reactants are everything on this side of the arrow because the arrow is showing where it's going to go, what it's going to change into. Okay. And then the products are going to be everything that are on this side of the reaction. Okay, now we have 3 more things. Yield sign. The yield sign is right here. Okay, it just shows you which way the reaction's going. Okay, and then we also have 2 other words. One is called subscripts and one is coefficients. The subscripts are these little numbers, and the coefficients are the big numbers that go in front, okay? So keep that in mind. I use those words all the time. That's what I'm talking about, okay? Let's move on. Now we're going to balance equations, and these are just some rules that I made up to help it go quicker and smoother for you, all right? So to balance these equations, we have to get the same number on the sides. So to get them the same, we want to find something that's different first. So that's the key. So we have to find something different that we can change. And look, I put little hinters here too, so you know. Now it says start with BR, okay? So if we look on our thing, we have 3 BRs on that side. We only have 1 BR over here. So we have to fix that. Now we can't write small numbers anymore because those formulas are from last section. Remember, we got those numbers from the charges, right? That's already set. You can't change those. What we're going to change now is the coefficient, all right? And so we have 3 BRs on the left. If we put a 3 on this line, that gives me 3 BRs on the right. I fixed it. But when you fix that, it changes the K's, right? Now, remember there's invisible ones behind here. So 3 times 1 BR is 3 BRs. That equaled it out. 3 times 1 K means I have 3 Ks. Well, I go over to the other side, and look, I only have 1 K. So what times 1 equals 3, right? 3. All right? And then I kind of ended all that. Let's go back here and look at these aluminums. I have 1 aluminum on the right. I have 1 aluminum on the left. Bing, bang, boom. I'm done with that. Okay? See how that works? It's kind of tricky. It takes time. Okay, this time we're going to start with the P. I put where the start. I'm going to mark where the start on these because half the battle is knowing where to start. And so this time we're starting with the P's. And so if I look at that, I have 4 P's on this side. I go over to the other side, and I only have 1, right? 1 P. So I have to make it the same. So think of it this way. 1 times 4, there's 4 P's on the left. 4 times 1, there's 4 P's on the right. Okay, you're multiplying, not adding, multiplying. Now look what that did to our BRs. We have 4 times 3, which is 12 BRs. We have 12 BRs on the right. we have a 2 down there. So what times that 2 equals 12? Right? 6 times 2 equals 12. All right, see how that works? Okay, we're going to start this next one. This one doesn't really matter where we start. If we start with these BRs, that will work for me, okay? So let me check my battery. I got 6%. Okay, I'm trying to get this done. So we have 2 BRs on the left. So 1 times 2 BR on the left, that means there's a 1 here. 2 times 1 BR on the right. But now I changed my LIs. I have 2 LIs on the right, and I want to have 2 on the left. I changed my CLs. Now I have 2 times 1, that's 2 CLs on the left. And I go over here, and looky there. There's a 2 there. So 1 times 2 equals 2, and that one's finished. All right. Oop. My thing just said low battery. All right, let's move on my computer over here so I can write. So if I'm looked off to the side, I'll just turn my head a little bit here. We'll see if this helps, okay? I might get, you get the profile. You get to see my microphone. There we go. Okay, so now we're doing this next one here too. So we have, this is the place to start. Now I always like to say we start with the things with the most stuff happening, right? I call it the most obnoxious because it has the most stuff going on there. That's probably the best place to start. And so let's start with that. So what we have here is we have 3 SO4s. Right? What? Mr. Arnold, how can you do that? If it's in parentheses, that's a polyatomic ion. We just treat that as one thing. So let's treat it as one thing and make our life easier. That's why we're using it. Okay, so we have 3 SO4s on that side. So we need a 3 in front of that because there's an invisible 1 behind it. That's 3 SO4s on the left. Okay, we can put a 1 here. Let's put a 1 here right there. Hold our space. Now let's go and do the SO. Let's do the CAs. Now I have 3 times the invisible 1 CAs on the left, and I have to have 3 on this side. So 3 times 1. All right. Look at the BRs now. 3 times 2 BRs, that's 6 BRs. So what times 3 equals 6? I hope you're saying 2 to yourself because then you'll be saying it right. Okay, and we just follow that pattern. Now, if you want to pause this and try to do these and see if you can get them right, that'd be awesome. I'm going to go through and I'll do each one. So if you want to do one, then pause, or then pause it, do one, and then check your answers. Unpause me, listen to what I do, and then just keep following that pattern. Okay, and I think that will help. Now. I'm going to do the one that has the HI needs the next higher multiple. I'm going to do that one last because that's the hardest one on the paper. Okay, let me keep going on this. So I'm just going to go and just do them fast here. So I have 3 NAs on the left. I have 1 on the right. So 3 times 1 equals 3. That changed my Fs. Now I have, oops, I am going to start somewhere else. You know what? Because I said if you start the most obnoxious one, it makes it easier. This one's a little bit more obnoxious. It has 2 subscripts, right? Let's use it first. It'll save us a round. Okay, so here we go. We have 2 P's on the right. So we'll put a 1 in front of that, right? And so we have 2 P's there, so we need a 2 in front of this. Now that changed that 2 times 3 for NA, so that'll give us 6 NAs. So we need to have 6 NAs on the right. That gave me 6 Fs. 3 times 2 equals 6 for the Fs. And just as a check, that's 3 CAs, and I already have 3 CAs, and I know I'm done. All right. If you got it right, it's going to match up at the end, and you'll know you're right. I'm skipping that next one. I'll come back to it. So we're going to probably start with, it doesn't matter. These 2 look about equal. We're going to start with this one, I guess. So we have 3 LIs on that side. So we have a 1 here. Oops. So I'm going to put a 3 in front. That gives me 3 LIs. That also gives me 3 BRs. I'm going to go to the other side. I only have 1, so I'm going to put a 3 in front of that. That gives me 3 NAs on that side. And I go back and, oh my goodness, there's a subscript 3 there. So I can pop a 1 in there, and that will be equal. And now I'm back to where I started. And I just want to check. And yes, they're the same. And I'm done. All right. Next one. Oh, let's start with this, right? So we have 2 OHs on the left, 2 OHs on the right, 2 H's on the right, 2 H's on the left, 2 BRs on the left, and looky there, we have a 2 already, so 1 times 2 BRs. 1 MG, 1 MG, and we're done. We have 2 more to go. All right. We have, let's start with this, right? Most subscripts, 2 FEs, put a 2 in front of that gives me 2 FEs. 3 times 2 OHs, that's 6 OHs. A 6 in front of that would give me 6 OHs. 6 Ks now, I have 6 Ks. 3 times 2 is 6 Ks. 3 SO4s, I already have 3 SO4s, I can put a 1 there, and I know that I'm right. Okay, now this last one we're going to do. It's like the least common, the least common multiple in math class, you know, when you have different numbers, like say you have 2 and 3, what's the smallest thing you can make it? That number that will fit both of those. And the answer is 6. 2 times 3 is 6. That's the smallest number. I mean, you're not going to use 12 because that can be reduced, right? You're going to use the easiest, the smallest number. That's what we want. That's what's going to happen here. And I got a mouse in the way. Let me move that mouse over. Okay, so here's what's going on here. We have 3 I's here. We have 2 H's here, but they're going to join together, right? Well, they're actually splitting apart, but they're coming from the same compound. So we're going to have 2 H's and 3 I's come from this other side, right, in right multiples, but we have a 1 and 1. Okay, so you see our dilemma? So what's the smallest number that both 2 and 3 fit into? And the answer to that is 6. So if we can make this 6, because we know it's the smallest number that works with those 2 numbers, then we can just work from there. Now that's 6 H's, so 3 times 2 is 6 H's. That's 6 I's, so 2 times 3 is 6 I's. And let's check our manganese, our Mn there. There's 2 Mn's, and we go back to the other side, we put a 2 in front, and we're done. Okay, so that's how you balance. Now, I also have included in the class, just started it today, they did not finish, was the assignment 212. They started it. It's the same thing as the balancing, all right? And if you look on the bottom of that page, the key's down there. But I want you to try them. I want you to make sure you know how to do it. That's what we're trying to do. We're trying to learn. It just takes a little practice. So try to do one. Look on the bottom, see if you got it right. Try to do the next one. Look on the bottom, see if you got it right. You got that pattern. I wouldn't do them all, because if you're screwing it up and you do them all, you're going to do them all wrong before you realize it. If you do one, and you see that you made a mistake, you figure out what that mistake is, you try the next one, you see if you made a mistake or not. If you didn't, you know, you just keep going through that process, and I think you'll enjoy it. I think it's a good time. It's fun for me, but, you know, I am a science teacher, so hey, have a great day.